Hello students, so today we are going to revise the chapter metals and non-metals. Now, there are so many different type of substances, but basically we can divide these substances into two main types, metals and non-metals. First, we will discuss the physical properties of metals and non-metals. Now, what do you mean by physical properties? So, the properties which are visible that can be known as the physical properties. First is malleability. Metals are malleable. This means that metals can be beaten into thin sheets with a hammer. And this is the characteristic property of metals. Like for example, iron. The iron nail can be hammered to form iron sheets. And that is due to the property of malleability. Now, non-metals are not malleable. Non-metals are brittle. This means that non-metals cannot be beaten into thin sheets with a hammer. Non-metals break into small pieces when hammered. Your pencil lead is made up of graphite, which is a form of non-metal, and therefore the pencil lead breaks easily as it is brittle. Next is conductivity. Metals are good conductor of heat and electricity. This means that metal allow the heat and electricity to pass through them easily. If we hold one end of the metal spoon, like an aluminium spoon, in hot water, then its other end becomes hot very soon. This is because the metal of spoon conducts heat from one end to the other end quickly. Copper, silver, gold, aluminium, and iron metals are good conductors of heat, whereas non-metals are poor conductors of heat and electricity. This means that non-metals do not allow heat and electricity to pass through them. A form of carbon element, diamond, is a non-metal which is an exception as it is a good conductor of heat. And the other form of carbon element, which is graphite, is a non-metal which is a good conductor of electricity. So these two are exceptions in non-metals which are good conductors of heat and electricity. Next is ductility. This means that metals can be drawn into thin wires. We all have seen appliances. In that appliances we can see that the wires are made up of metals. The properties which allow the metals to be drawn into wires is known as ductility. Non-metals are not ductile. This means that non-metals cannot be drawn into wires. They are easily snapped on stretching. Then next is sonorousness. Metals are sonorous. This means that metals make a ringing sound when we strike them, whereas non-metals are not sonorous. This means that solid non-metals do not make a ringing sound when we strike them. Some of the more properties are lustrous. Metals are lustrous or shiny, whereas non-metals are not lustrous, they are dull. This means that non-metals are not shiny. They are dull in appearance. Metals are usually strong. They have high tensile strength. This means that metal can hold large weights without snapping. Therefore, the bridges are made up of metals. Whereas non-metals are not strong, they have low tensile strength. This means that non-metals cannot hold large weights. They are easily snapped. Metals are generally hard. This means that most of the metals cannot be cut easily, and therefore they are being melted, and then proper shape is given to them through the mold. Most of the solid non-metals are quite soft. This means that most of the solid non-metals can be cut easily. For example, sulfur and phosphorus are soft non-metals which can easily be cut into pieces with a knife only. Hence, these were the physical properties of metals and non-metals. Next, we are going to revise the chemical properties of metals and non-metals. First is reaction with oxygen. Now metals react with oxygen to form metal oxides. And metal oxides are basic in nature. Like when magnesium reacts with oxygen, magnesium oxide is formed, which is a basic oxide. How do we know that it is a basic oxide? So when magnesium oxide is dissolved in water, magnesium hydroxide is formed, and when this solution is checked with the pH paper, the red litmus paper turns to blue, showing that it is a basic oxide. Non-metals react with oxygen to form non-metallic oxides. Non-metallic oxides are acidic in nature. Over here you can see the activity describing sulfur. So when sulfur reacts with oxygen, sulfur dioxide is formed. This sulfur dioxide, when dissolved in water, it forms sulfurous acid solution. And hence we can say that the non-metallic oxides are acidic in nature. Next is reaction with water. When a metal reacts with water, then metal hydroxide is formed along with hydrogen gas is released with a pop sound. Now sodium is a very reactive metal. Over here you can see how sodium metal reacts with water. It reacts very vigorously with water. Non-metals do not react with water. Next is reaction with acids. Most of the metals react with dilute acids to form salts and hydrogen gas. Like for example, magnesium reacts with hydrochloric acid, then it forms magnesium chloride and hydrogen gas is released. Next is the displacement reactions. What do you mean by displacement reaction? It means that when a more reactive metal is placed in the salt solution of a less reactive metal, then the more reactive metal displaces the less reactive metal from its salt solution. The more reactive metal becomes a part of the salt, whereas the less reactive metal is set free. Over here, you can see that 5 beakers are taken and 5 different solutions are taken with 5 different metals. Now, over here, why only in 2 of the beaker only you can see the color change and not in other? Because some metals are more reactive than the other metals, and the metal which is more reactive can only displace, and therefore displacement reactions. Now quickly we'll move on to the uses of metals and non-metals. Metals are very extensively used to make cooking utensils and water boilers for factories. Copper metal is used for making electrical wires for household wiring and the other appliance wiring. Aluminium foils are used for packaging, medicines, chocolates, food items and many other materials. Aluminium is also used to make aeroplanes. Iron metal is used to make nails, screws, nut bolts, etc. Zinc metal is used for galvanizing iron to protect it from rusting. Silver and gold metals are used to make jewelry. Mercury metal is used in making thermometers. Now some uses of nonmetals. Oxygen is a nonmetal which is used by plants and animals for breathing. Nitrogen is a nonmetal which is used in making fertilizers to enhance the growth of plants. Chlorine is a nonmetal which is used in water purification processes. Iodine is a nonmetal which is used to make purple colored solution called tincture of iodine and is applied on cuts and wounds as an antiseptic. Sulfur and phosphorus are the nonmetals which are used in fireworks. Sulfur is a nonmetal which is used in vulcanization of rubber. Carbon is a nonmetal which is used as a fuel. The forms of carbon used as a fuel are charcoal, coke and coal. So these were some of the uses of nonmetals. Now finally we conclude the chapter and I wish you all the best for your PA2 exams. Thank you.